Hi guys, good afternoon. So in the last session, we saw about dual hub configuration of DMVPN. Today what we'll see is about overlapping VPN. Okay. So lab scenario I had already explained in the last session.
I have done my practical in GNFP,
Hmm.
and there I get an error that needs to be completed.
Where, in which case? For what? Like in which case you are getting? Were you getting the routes? Did you check the routes?
Yes, sir.
Routes are there and not able to communicate. Start the lab, we'll see after class. Okay. Now see here. This will be our ISP. Then we are going to have two ASs. And then this side we'll use a switch. And this side also I'll use a switch. On this side I'll use two routers. On this side I'll use one router. So the overall idea is what? That both sides, the subnet is same. Hmm? CH? Okay. Wi-Fi. So this is ASA for the site one. This is ASA for site two. This is switch. This is also switch. This side inside R1 for site one. And this is inside R2. And this is, we can consider inside R3. Okay. So here I'll use the IP 10111. Here I'll use 10112. Again, here I'll use 10111. This will be 10110. This is also 10110. This side 11110. 11111. This side 12111. And here we'll use 12110. This is here. Okay. So how the communication will be, even if we create a tunnel, normal IPsec site-to-site policy-based VPN also if we configure. So in the access list, what you will configure? Same source, same destination. And when you try to ping from here, it will not ping. Correct? So what will change here? This implementation is exactly same as your site-to-site policy-based VPN on the ASA. Between ASA, whatever the configuration we have done, same configuration we have to do. Just one extra concept is there. What is the extra concept here? That in normal scenarios, what we are doing is we just configure the access list, we just configure the tunnel, and it's done. But here, this time, both the subnets are seen. So what we'll do, we'll translate them. We'll just translate both sides, right? So let's say this side, what I'll do is I'll do the translation of my 10110/24 network to 172.16.10.0/24. Okay, is it clear? And this side, I'll do the translation of this subnet, which is 10.110/24 subnet. I'll translate it to 172.16 dot, let's say 20.0/24. I cannot translate it to the same subnet again. Otherwise, again, it will be overlapping only. Once I do this translation, so one thing you have to take care here, that this translation we are not going for, like we are not doing it for going on the internet. We are doing it only for going to the VPN tunnel. Correct? So that means when you will create the access list, in your access list, what you will mention? Translated IP. So we'll create the access list for a translated IP. And another thing you have to make sure is what? That I am using same CIDR value, right? After the translation also. So how this translation will happen? This translation will happen like 10.111 IP to 172.16.10.1, 2 IP to 2, 3 to 3. Same IP into same IP translation it will be. Why? Because these guys, when they will communicate with what? They will communicate with the translated IP. And these guys will also communicate with the translated IP.
Is it translated ID?
Where? This is static. This is actually what we will use here is policy net. Why policy net? Because I'm saying that I have to use it. I have to do this translation only when I'm going to this network. My destination is this. Otherwise, what will happen? If I'm going on the internet, also the translation will be done. But I don't want that. I want to do the translation based on destination. And in the destination, I will mention what? This 20 network. And it's
Translated IP is only on CSA for that while packet reach to that destination.
After that, yeah.
Source IP will be that 10.1.
No. It will be the translated IP on, because if it is 10.1, then this guy, when this guy will try to respond again, it will become same IP. Okay. And this guy, this ASA will never know what is the subnet on this side, because he will get IP the translated. They will get the messages from translated IP only. This thing is clear. So this is one extra concept here, that we have to use what? Policy net. And in the policy net, we will make sure, first of all, that in the policy net, that the translations are same subnet translation. Okay. And in the destination, we will mention what? 20.0. And this side, when we will mention the destination, it will be 10.0. Clear to everyone? Online people? Guys, the scenario is clear. Now, let me access the lab. And power on the EVG. Design the lab. Overlapping VPN. So we'll take 2AC. These are 2ACs. And then we'll take 2 switches, or only 1 switch, let's take. On the other side, we will directly connect. And then we'll take 4 routers. Four. And this will act as ISP. And this is our site 1 inside R1. Now let's connect all of them. So Z0 by 0, I will keep as inside. Not really required. We can directly connect it. Then Z0 by 1 on the outside. That's power on all the devices. This is overlapping VPN. /110/24. 110/24. This side 10. This side also 10. And then here we will use /110. This side 12 on 1. Now let's do one thing. Let's use these IPs as 10 and this one 11.1.1 and 12.1.1.2, what we are normally using. Then we have on the inside, this will be 10.1.1.10. This side same. This will be 10.1.1.1. This will be 10.1.1.1. Same here. This will be 10.1.1.2. So this is our lab will be. Now let's go ahead and do the basic configurations. First of all, yes, site 1, enable terminal host name, yes, site interface, v0/0, IP address 255.255.255.0. No shutdown. This will be 11.1.1.1. Then one route I will need. Then I'll say 11.1.1.10. This is site 1 ASA configuration. On the site 2, this will be same. V0/1 will be outside. 12.1.1.2. This will be 12.1.1. Then site 1 and site R1. Enable configuration terminal host name IP address 10.1.1.255.255.255.0. Noted down. This is it. Then we need one route. And 1.1. This is clear. All the inside R2. Then for site 2 inside R1. Only name will change, nothing else will change. Correct? Okay. Mhm. Surface 0 IP address 255.255.255 0. Now shut down. Let's go and take the access of the devices. ASA site 1. And then we have ASA site 2. Site 1 inside R1. Site 1 inside R2. Then we have site 2 inside R1. ISP. Okay, now. And now one by one, we'll copy the configuration. Copy. And this is ASA site 1. And then copy. And this is ASA site 2. Copy. Site 1 inside R1. Copy. Site 1 inside R2. Copy. Site 2 inside R1. And finally, ISP. Now, public to public connectivity should be there. Ping 12112. This connectivity is there. Now, since I have connectivity from here to here, directly I cannot go and create VPN. Why? Because I know that this subnet will overlap. So when I will give the policy also, I'll give the access list, source and destination have to be same. And if I will try to pin 10.1.1.1 from 10.1.1.1 only, so it will be self-ping, right? It will never send out the packet.
I think self-ping will get a success.
Yes. Okay. Now, what I'm going to do is, first of all, we are going to create translations. So what are the translations that we are going to perform? So on site 1, I'll say that 10.1.1.0/24 will be translated to 10.0/24. This is the translation we will do. On site 1. And on the site 2, this will be 10. These are the translations that we are going to do. Okay, so let's go and perform the translation. Configure policy now. Okay, this the source and destination subnets are overlapping with each other. We need to separate that with the help of translation. Okay. Now we want the translation to happen only when it is going for VPN path. So we will configure NAT become destination. That is policy. This is clear. So first of all, yes, it site one. So we need to configure what NAT here. So for configuring NAT, we need to first of all create what objects. Okay. So let's go here. ASS site one. Now here two objects. First of all, I need to create 2 or 3 objects. One is for my internal network, second one for my translated IP, and third one for my destination. 3 objects I need. Okay. So I'll say why 4?
Type 2 to destination.
Hmm?
Type 2 R1, R2 to destination.
Which destination?
Type 2 R1.
No, this side we will not configure here. We will only configure that translate this subnet into this subnet when you're going to this. That's it. So only 3 you will require. Okay. Understand. See here how the configuration will be. Object network, first of all, my inside subnet or inside network. And here I'll say the subnet I want to use is 10.1.1.0 This is my inside subnet. Okay. Then I want to translate it. Object network inside network translated. Okay. So again, this will be what? Subnet. And in what I want to translate? This one. Another object. Object network. And then I'll say destination. Okay. Or let me name it site. This is clear. And my site to subnet is what? 20.0 255.255.255.0. Clear? Now I'll configure NAT. So I'll say NAT and I want to configure NAT from where to where? inside to outside. Then I'll say source, right? Now after source, what I have to say? Static. Now what is it? What it is asking me for? Real source. Who is my real source? My inside network. My inside network is the real source. So I'm saying that I want to translate my inside network. Then after it is asking me about mapped source. That means this will be inside network, real source. It will be mapped with what? It will be mapped to translated IP. So this one. Okay. After this, if I ask, so it is asking me about destination. Destination. My destination is also fixed. What is my destination? Now it will ask me about, first of all, mapped destination. So I don't control the translation on the other side. So does whether it is mapped or real, it will be same only. Eventually, I'm going to what? Site 2. Where I'm going? My destination is site 2. So my translated destination, real destination, this is only the destination. This is my map, and this is my real destination. This is clear. This is my map configured. Is it clear? Yes. Now see here, show history. This is what we have configured. Site to site 2 because mapped and real, same only. Destination side we cannot control, right? So this is what we have configured on ASS icon. This is a bit quite a bit comment. Yeah, first of all for source, second time for destination. Which one? This one. Here what I'm saying that this is my inside network translated to translated. Can I control on the other side? No. So I'm saying real or mapped also same, real also same. Kind of it is saying that this is my real destination and it is getting translated to this one. So I cannot control on the other side. So that's why we will give always same only. Okay. Can be anywhere. If you have two sites and you gave a tender to some other different organization for configuration. So what they did everywhere, the inside subnet they configured same. Now what we'll do? You're not going to go and change the subnets everywhere, right? That's why.
This scenario, like you are connected with Wi-Fi. In that scenario, this is
with
we are connected with Wi-Fi. So in this Wi-Fi configured with the phone number.
No. If you are talking about your home networks, so in your home networks, you are not using only interface level path. That's it. One IP given by your ISP on the outside interface of your router, and you are getting transferred to that IP. That's it. This is being used in the organization only, policy net. Okay, whenever you are going from one site to another site, when your destination is fixed. And when we are using internet, our destination is not fixed. Okay. So this is what we have configured in the ASA 1. Now similar concept we can configure in the ASA 2 also. Copy. Paste. Now what will be the change? My inside network will be as it is. Just this will be 20. And this will become 10. Okay. And instead of site 2, this will become site 1. And here, this will become site 1. Now, what it says that my inside network, which is 10.110/24, will get translated to the translated IP, which is 20.0 when you're going to the destination site 1. Clear? Same thing, let's configure. Done. Now, once the NAT is configured, now we can go and configure our IPsec as usual. Okay, only we have to take care of that in the IPsec configuration, your ACL will have source and destination as your translated IPs. Okay.
Type 2, if you want to convert ping with arrow RT.
Then you will ping in the site 2. From the site 2, if you want to ping inside R2, you have to ping 172.16.10.2. Because same IP to same IP translation, and it is bidirectional.
And while pinging, we forget that translated.
If imagine, if I will say
translation is happening on PSA, right? Kind of packet from.
That is what I'm telling you, right? That imagine you say that okay, I'm not pinging with the translated IP. In that case, what will happen?
That in that case, the router will ping itself.
No, it's not. It's IP. Let me explain. See. From here, okay. From the site 2, you are pinging what? 10.1.1.3, right? But on the site 2, will there be only one IP? In the real scenarios, will there be only one system? No, right? Same 10.1.1.2 can be on the site 2 also. So that means instead of pinging this one, you will be actually pinging one IP in the other site only. Yes.
Inside site 1, inside R2 will ping 10.1.1.1.
Then it will be self-ping.
Yeah. Inside R2 will ping.
Yeah. Okay, this one. Yeah. It will ping here. It will never ping site 2. Why? Because it will always check in the same network. It will never send packets to the gateway. Right? So for that reason, that is the reason on both sides we are doing translation, not only on one side. Otherwise, sometimes while understanding, you can say, okay, one side I have already translated, and on the other side I don't need because already two different.
So in this scenario, that we always have to do a static translation.
Yes. Okay. So you have to do the translation on both the sides only. If you do not do on both the sides, only one side you do the translation. So maybe you will ping from 10.1.1.1 and you will ping with like 172.16.10.1. The packet will travel through the tunnel, will come here, will come here. Correct? But when it will reply, it will be source 10.1.1.1. Destination also what? 10.1.1.1 only. That will again conflict self-ping. Is that clear?
So that like in site 1 case, right? Will give a command that translate 10.1.1.0 means entire network to this entire network 172. So he says 10.1.1.1 will ping. And first time ASA will give that 10.1 IP 72. And then if 10.2 will ping, it will give
10.2.2. This is static translation, fixed translation. Same IP to same IP. No, we don't have to do anything. We mapped with 10.1.1.0/24 with 172.16.10.0/24. Yeah, it is permanent. It's a static translation.
But there is no, but it's site 1 kind of. Site 1 after 1 ping to site 2 after 2.
Okay.
Site 1 after 1 to ping site 1 after 2. Then you automatically translated to.
No, then in that case, if site 1 router 1 is pinging site 1 router 2 only, then the traffic will never go to the ASA, no translation.
But if I want site 2 router 2.
In that case, you will ping with 172.16.20.2. In that case, you will ping with same IP, but translated. Is that clear?
Policy not translated automatically. Policy not is translated automatically.
In PolicyNet also, we have mentioned that source is static, source translation is static, and destination translation is also static.
After configuration, the first will ping from 10.1.1.2. Then what if ASA site 1 will be later 10.1 IP to 10.2?
No. Even if R2 is pinging first, it will get the IP .2 only. It will not get .1. That's why this is static translation.
.1 is reserved for
.1 is reserved for .1. Understood? Because see, that was the specific reason behind using the same CIDR value. That okay, IP number 1 to 254 with to IP number 1 to 254 only. There is no random translation. Is that clear? Now, next thing we need to configure IPsec as usual. So let's go and configure IPsec. Configure IPsec IPv1 policy based site. Okay. Already we are configuring it. Just here, one thing you have to take care. Here, the ACL will be configured for translated IP. Okay. That means source will be 16.10.0 and destination will be 16.20.0. And on the side 2, it will be reverse. Okay. Okay. Now tell me the comments for configuration. Yes, sir. Site 1. Crypto. Yes. IP1. Policy 10. Authentication pre-share. No. Group 14 not supported. Right. Encryption. AES lifetime 86400 we can say. Good. Tunnel group. Not required. Yeah, on this. 12112. This is my peer IP. Then 5 IPsec line to line VPN. Then same comment, but there will be no type. Just IPsec attributes. Then we shared the D is extra. I think pre-shared key it will be. Okay. Cisco. That's it. Crypto. No, I think first IPsec will be. Transform search, ESET, ESP AS, and then ESP HMAC. Right. And after access list, then call it tunnel. Commit. And first of all, not host it. Correct. Translated IP here. No host. Host is only for single IP. That we were giving for single IP. Right now, entire network. Whenever you are giving for single IP, then you can use host. If you are using entire network, in that case, subnet mask and network ID. Crypto map, C map, and then search here is 112. This much will be same on the search IPv1 concept. MAC address and the tunnel. And then we will apply it on the interface out. Then we will enable to KV1 enable on the outside interface. Let's copy and paste. Oh no, wrong. So some error is there. Crypto map, CMap. Hmm? No, some crypto. Okay, space it will be, not hyphen. This is a mistake. Copy, paste it here. And for site 2, just the peer IP will change. ACL will also change. This will become source. Source become destination. Destination becomes source. So, now let's show running. Run up. So this one we will remove. Here, configure group. Only now correct we have, and also access list. Show running access list. This one access list we don't need. Now access list is also fine. Okay. Now we will verify whether we are getting tunnel setup or not. So the 0 by 1 I will capture because tunnel will be established between ASA and ASA. Now let's try to ping. Now let's say from inside R1, site 1 inside R1, I want to ping site 2 inside R1. What IP I will ping? After ping 172.16.20. So main mode, quick mode done, and you can see I have the communication. Okay. This one more. So this is clear. We are able to ping. And if I try to ping from site 1, now let's say if I try to ping to like site 1 R2, so what IP I'll ping? So 172.16.20 or 10?
10 or 10.
10, right? This is site 1.
Yes, we are also doing things from site 1.
Okay, site 1.
Yes.
Now we are site. On site 2 inside R1.
10.2.
Now it will be 172.16, 10.2. 172.16, 10.2. So this is static translation, 1-to-1 translation. Even you can check also. Okay, if you want to check trace route,
This will be done only on 2 sides. This will be done only in 2 sides.
Which one?
Like this static translation. But if we have 3 sides.
If you have 3 sides, that will become multi-site configuration. DM VPN. DM VPN.
That also we have to do that.
If you want, you can do that. Yes, we can do that. If you have same subnets everywhere, then in that case, you can do. Okay. Now here, you are not seeing any hope. Why you will not see? Because this IP actually doesn't exist. This IP 10.2, this really doesn't exist. This is a translated IP.
That same happens. This will be goes till 30.
30. After 30 ops, it will go. Yeah, even if you press some escape sequence, nothing. Nothing.
Ask you yesterday, but that's 12:30. So I think
it will check all the 30 ops. Right? You got the idea, right? This is your overlapping VPN concept.
Yesterday's last
See, that thing is like you have to understand. This is not a physical IP. If it was a physical IP, like actually, if I was looking for 10.1.1.2, it would tell me. Okay, like from 10.1.1.1, if I will try. Okay, if I say first of all, from 10.1.1.1, that trace route 10.1.1.1. So it will be self-ping only one hoop directly itself. This is router 1, right? If you will trace route again directly, it will come here. Because it is in the same network. So if IP is real, you will get the trace route. But the IP doesn't exist, how will you get it? Right? So in this case, same thing is happening.
While I am thinking that loopback interface, then that while I am thinking that loopback interface.
Ping is, see, right now I'm able to ping it.
Sorry, ping not.
So if you're doing trace route, now 127.0.0.1, you're trace routing, right? Correct?
In my scenario, I am thinking that loopback interface.
Which?
Like loopback. Not self loopback. Like that is
DM VPN.
DM VPN multi-hoop. Right? And from like scope 1 to scope 3 loopback interface, I'm thinking that.
I'll see that. So this will go till until 30 ops. This is clear. Online people. So configuration, I'll say one posted in the drive. Now tomorrow, get VPN. Get VPN. GET. This is over. Clear? Okay, then this is it for the day. Will not be able to complete actually. That is the problem.
We are covering 4 million.
No, it's not like that. We will not be able to complete. So half configuration today and tomorrow will not be good. So that's why. Okay. So tomorrow we'll go with the GAT VPN. Then after we have VRF Lite Aware VPN. Furthermore, we'll start with IKE version 2. IKE version 2. Right now we are configuring IKE version 1.
23rd of September.
We'll complete it. If we have few classes left also, no need to worry because we will start with ESA, right?
Yeah.
So ESA will be like barely 3 sessions.
Only 3 minutes.
Yes. Stealth was 2-3 sessions, ESA 2-3 sessions. CWS will be like 2 sessions or 1 session. Okay. ESA.
Yeah, ESA is one source.
Yeah, because that is about email security, right? So there we'll understand about ESA, we'll understand how the mail flow is, and then we'll understand about the protocols SMTP, POP3, and IMAP. These things are required. Okay. So we will have 1-2 sessions again in that week. So if needed, otherwise we will complete before that. Okay, guys, then I'll see you guys tomorrow. Have a good day.